So more practicing counting and probability. So we have a lock that's been added to a door. The code on the lock consists of 2 letters followed by a digit. A letter can be used only one time, so no repeating letters. So no repeats of the letter. So I've got to remember that. It's important, right? Because once I use a letter, it can't be used, so I have to do a subtraction. All right, so the first question, how many? So how many, remember, is just the count. How many codes are there? So this would be the big set. This would be the total set. Total possible. Which is important because it's what I'm going to have to divide by. Alright, so I've got a letter. So those are my letters. Letter 1, letter 2, and then my number. Right? No repeating my letters. So my first letter there are 26, but I've used a letter. So for the second letter there's only 25. And then I get to do a single digit, which there's 10 of those. So it's 26 times 25 times 10. So that's 65,000 total codes. Right? That would be the big group. Total possible codes. If a student is randomly guessing the code for the lock, find the probability. Alright, so this would be probability events over total, which we're going to use the total that we found up here. So what's the chance? So probability that they guess it right. Well, there's only one correct code, right? One correct code. So they only have one shot out of 6,500. Again, I'm going to leave it like that because this decimal's pretty small. It's like 0.0001 something. Alright, so I'm going to leave it exactly 1 over, again, 6,500 would be the probability. Alright, so suppose a student tries 50 times, right? Randomly guesses 50 different codes, find the probability of the door with those. So remember, they're doing this 50 times. They're going to guess 50 times. Each guess has the same probability. Right? Each time they make the guess, it's 1 out of 650 shot. So it's 50 of those. So it's 50 times 6,500 or 50 over 6. Right? This is the percent chance it's going to succeed. This is how many times you try. And so it comes out to be 1 out of 30 or 0.0077. Very slim chance. All right, less than 1% shot. All right, next example. All right, this is going to be picking out of a group. We're going to do more groups in the next section. There's actually 2 counting techniques that we use when we pick groups. All right, suppose I have a class that has 15 women and 10 men. From this class, we're going to select a president, a vice president, and a treasurer. All right, so we have 25 total people if I add up the men and women. How many possible election outcomes are? So how many, which would be the count. So we're going to pick a president, and we're going to pick a vice president, and we're going to pick a treasurer. Didn't say anything about not being allowed to pick the same person, right? Oh, we're going to assume that, though. I think with these you want to make the assumption. Assume once you've been selected, like if you're picked for president, you can't be picked again. Which would be the way most elections are, right? Once you've picked somebody, they can't be picked again. So we're going to have a different president, a different vice president, and a different treasurer. So we can't pick the same person twice. So we'll pick president first because that's the most important one. So out of all the people, we're going to pick president. So there were 25 choices for president. Then we're going to pick a VP. Well, we've already picked the president, so there's only 24 left for the VP. Now we've picked 2, and so there's only 23 left to pick for the treasurer. And so remember, the and means we multiply. It's 25 times 24 times 23, and so that's a grand total of 13,800 outcomes. Total. All right, which is important because we do need to know the total, right? If we ever go to probability, that's the total number of outcomes. All right, how many, which again would be a count, consist of only women? So what's the number of ways out of my 13,800, how many of those outcomes consisted of only picking from the women? So we're only picking from the women means we only have the 15 women to select from. We're still going to pick a president, a vice president, and a treasurer, but we're only selecting from the women. So for the president, there were 15 women. Remember, once we've chosen one of the women, there'll only be 14 left for the vice president, and only 13 left for the treasurer. So it's 15 times 14 times 13. So 2,730 outcomes of only women. All right, so out of the 13,800, 2,730 of them are outcomes where only women won president, vice president, and secretary. All right, now we're going to do the chance. All right, now it's the probability, which is nice that we have the first two numbers. Probability is my event over my total, which we actually have those. The event is that we only get women. Well, that was the number 2,730 out of my total possible outcomes, which was my 13,800. All right, so we simplify that. Fraction simplifies the 91 over 460, or the decimal point 198, or the percent, 19.8%. Again, on the homework, just make sure whatever they ask you for, if they ask you for the reduced fraction, give it as a reduced fraction. If they ask for the decimal, round correctly. If they ask for the percent, round correctly. Right, next one, again, we're looking for a probability. Right, so probability is the event over the total. All right, the total's the same, and that's not going to change. It's the event I have to figure out. Well, the event is that I only get men. So event is we only pick men. And there were 10 of them, right? And so I'm going to do my event first. How many in my event? So I'm picking president, vice president, and treasurer. But this time I'm only selecting for the men. So there were 10 men to start off. So 10 for president, 1 less for vice president, and 1 less for treasurer. So 10 times 9 times 8, which is 720 outcomes where we only have men. That's not the answer. That's just the number. To find the probability, we take the 720 in our event divided by our total, which is our 13,800. And so that fraction comes out to be 6 over 115, or 0.052, or 5.2% chance, depending on how the question is asked. All right, so that one we had to find the event and then divide by the total. The next one, find the probability. So again, probability. At least one of the position will be held by women. So probability, you get at least one woman elected. Well, remember the at least cases? We talked about this at the end of the 5.1 notes. The easier way to do that is taking 1 minus the 0 case. The 0 case is no women. Well, the no women means you only get men, which we have that. That was the previous one. 1 minus the chance, and again, I'm going to use, do not round to the end, so I'm going to use the fraction. You can use the big fraction if you wanted to. But I'm going to use the 6 out of 15, 115, 6 out of 115. So 109 over 115, or 0.948. Again, you have a 94.8% chance of getting at least one woman, meaning it's the opposite of getting no men, right? You get 1 woman, or 2, or 3, or 3 is all we're going to. So again, all of those outcomes are possible. All of those outcomes being possible, there's a 94.8% chance. If you take the previous answer and that one, add them up, it should be 100% of the outcomes. All right, I'm going to do the next example, and then we'll stop there, this video part there. There's a total of 3 area codes are the first 3 numbers, and it kind of tells you where you're located. Most of the state is 309. There's a couple of exceptions, the Chicago area and some other areas. So 217, 309, and 318 are the different area codes. All right, so those are the different area codes for the state of Illinois. Assume all 7 digits for the rest of the numbers are possible. So again, you can repeat. Technically, I don't think they ever hand out these numbers, but technically, you could have a phone number that was 3333333. You write all threes. Although I do think they very rarely, I think they do throw those out. But we'll suppose that we can do that. How many phone numbers are there for the downstate? Again, downstate means we're not doing the Chicago area. Alright, we're just doing the downstate. So those are the 3 for the downstate. How many? So we're not looking for probability, just want total number. So we need to figure out, so there's 3 different cases. There's the number of area codes for 217 possible, or 309. So the numbers for the code 217, or the numbers for the code 309, or the numbers for the code area code. I say code, but it's the area code. 618. So those are the first 3 digits. Then you have 7 digits remaining that you can have your phone number as. Right? So there would be, so what you have to figure out is for the 217, 1, 2, 3, 4, 5, 6, 7, the digits that go with that, plus, remember OR is plus, the 309, plus the 7 digits that go after that, 2, 3, 4, 5, 6, 7, plus the 618, and the 7 digits that go after that. 1, 2, 3, 4, one more. Each one of those 7 digits, you can have any of the digits. So remember, the digits for 0 through 9, you can have any of, we're going to allow all of them to work, and we're going to allow repeats. They don't say you can't repeat. And so basically for each one of those spots, there's going to be a 10 in. I have 10 for each of those. And it's a multiplication because you have to have 7 digits. You can't have 6 digits. So 10 for all 7 spots. Made myself enough room on that. So 10 times 10, 7 times. 10 times 10, 7 times. 10 times 10, 7 times. So for each area code, there's 10. Remember this means? That means 10 million, right? 10 million for each of them. So 10 million plus another 10 million plus another 10 million for a total of 30 million possible phone numbers. Now, which again would cover majority of the state. We're even throwing out the cases where you get the repeating digits. Right, but that would be the total for each one of those. Alright, we'll stop there. I'm going to pick up independent events in my next video lesson.